and thanks everyone for joining us for another one of our AutoML tutorials, following up our exciting tinyML AutoML event in early June. We only had 3-minute demos from each of our participants, so we definitely wanted to take some time and do deeper dives with each of the participants. Today, we're doing a deep dive with SensiML, and I'll introduce and hand it over to them in just a bit. First, I wanted to thank all of the tinyML strategic partners for committing to take tinyML to the next level. You'll see a lot of the companies who participated in the tinyML Summit, SensiML, and others are all part of the tinyML sponsors, kind of helping take this new idea, this exciting market, these exciting opportunities to the next level, building the enabling technology to make it possible. If you're interested in learning more, if you haven't already, please join the growing Tiny Machine Learning communities, both on Meetup and in LinkedIn. The QR codes and the links are right there on the screen, so please join. You'll find all kinds of great talks and great information. There are a number, you should also subscribe to the tinyML YouTube channel. This video, this event will be recorded and posted there within the week or so. And you can find a lot of the past tinyML auto machine learning deep dives, as well as the recording from the big event we had in early June. So go take a look there. All the talks are always available. There are a number of upcoming events from tinyML as well. The tinyML on-device learning forum will be August 31st through September 1st. 2 really interesting days of talks, both from academics and industry people, all talking about how could we move from training our models in the cloud and then deploying inference on the device to doing everything on our tiny devices. A really interesting event. Should be really a bunch of really great talks. So take a look at the link below and go ahead and get registered. For an in-person event, the tinyML EMEA Innovation Forum 2022 is in Cyprus, October 10th through the 12th. The call for presentations or papers is still open for another couple of weeks. So if you're interested in participating, signing up to attend, sponsorships, anything like that, all the info is on the screen. Please, kind of get in contact with the organizers there. So let me introduce Ehsan Kourkchi. As the chief data scientist at SensiML, Ehsan's involved in building and testing a variety of machine learning models based on the best practice algorithms. He actively explores new avenues to generate efficient models for tiny devices that fit within the AutoML framework of SensiML. Prior to SensiML, Ehsan's been involved in many research areas in physics, cosmology, and astronomy, and his researchers benefit a lot from novel data science and machine learning methodologies. He's gotten to work with all kinds of telescopes and has lots of skills in software development, database management, and designing graphical interfaces for multiple platforms. We also have Marc Giroux. He's the software development lead and one of the founders of SensiML. Marc has a range of passions in software architecture, design, application development, and clean coding standards. With over 12 years of experience in the industry, Marc thrives in leading the direction and focus of software engineering and product architecture to push for quality and success. Before SensiML, Marc worked as lead software engineer for Intel and John Deere Landscapes. Previous roles included software development lead for Intel Knowledge Builder, lead mobile engineer for Intel on Oakley Radar Pace, and lead software engineer on the John Deere Landscape application suite. Marc's role in SensiML is combining effort of managing project direction and designing and implementing the software architecture and flow for the SensiML Analytics Toolkit. So, Marc, I'm going to turn it over to you to take us through SensiML's products.
All right, great. Thanks, Elias. So, hey, everyone. Like Elias said, my name is Marc. I'm joined by Ehsan here on the SensiML team. I'm one of the founders and software development leads, and I'm going to be walking you through our toolkit. Let me get this off of the screen. And so, in case you don't know too much about us, we're from SensiML. We provide a software solution that makes it easy for developers to make IoT AI machine learning applications for low power devices at the extreme edge. And so we started this project we actually started back in 2012 at Intel. And yeah, so at SensiML, before we jump into the actual software, I just wanted to also mention that everything we show today, we do provide a free community edition of our toolkit. And it gets you the entire workflow. There's just some minor, things that are limited in it, but you do get to use all of the tools. You get to download a model and use and generate the C code for the model to flash onto a device and test it all out yourself. So at SensiML, we kind of, we've been in the industry for quite a long time, and there's kind of three main problems we see with building machine learning models. The first two, a lot of people, put a lot of energy in focusing on them, which are building algorithms that are going to detect your events, number one. Number two is generating the code that is going to be low power and fit on the edge. The third problem we don't see a lot of people put a lot of energy into, and we think is just as important as the other three, and that is doing the data collection and labeling of your training data set. So we've found when you build a model, chances are the first model you build is not going to be perfect. You're going to have to add new data to it. You're going to have to modify your existing data. And so we put a lot of energy into building out tools that make it easy for you to relabel data, change your data, add data to it, and rebuild your model with not a lot of effort. And so today, I'm going to be going through our entire workflow, but I will be putting a lot of emphasis on the data collection side of things and labeling side of things. I do suggest, so before I get into the software, I do suggest, afterwards you might check out our documentation. I'm going to be going through one of our application examples for a boxing demo with IMU, accelerometer, and gyroscope data. But we do support any sensor that's time series data. And so, microphone, temperature, and anything you want to use. We have, and I suggest checking out the left-hand side here. We have a lot of tutorials for how to use our software for audio use cases. We have guitar note tuning recognition case, a smart lock demo, and industrial predictive maintenance cases. So like I said, we're going to be going through a boxing workout demo today. And so this is using IMU data to detect successful punches from a boxing glove wearable. And so we're going to jump into the first tool in our toolkit, which is the Data Capture Lab. The Data Capture Lab is the tool that it does all of the data collection and labeling from a device. So to start, in the SensiML toolkit, we have the concept of projects. And so a project is all of your collected training data. It consists of all of your models that you've built for this project. And your project is saved both locally to your computer and saved in the cloud. And so I think that's an important distinction, is that this does work offline. You don't need a connection to the cloud to do anything in the Data Capture Lab. You don't need the cloud connection until you switch over to build your models. And so let's open up a project here. So I've already created this project earlier so that we don't have to go through a lot of the nuances of setting up labels, but I did want to just point out that, so this is, like I said, our boxing demo. These are labels that I've created myself for uppercut and jab and hook, but the labels can be customized to be whatever you want, and you can set your own colors for them. And yeah. So the first kind of question I'm going to go over is, how do you get training data into our toolkit? So we have the ability to capture sensor data from a device in real time. But before I get in, so that's what I'm going to start off by showing. But before I get into that, I also did want to just mention that you can import external sensor data via a CSV or WAV file format. And you can import pre-labeled data through what we call our DCLI format, which is a JSON-based format that is documented on our website. And so it's an important distinction because if you have your own tools for data collection, you can keep using them and then import them via these formats. And not only that, we do let you export all of your data and labels back out of the data capture lab so that you can keep using any sort of external tools you're using to label your data and import them back in. So let's jump into capture mode. This is where we are going to do live collection from a device. So the first thing to do is select your device. And so we have a range of devices here that are supported from all the big players in the industry. But I also just wanted to point out that you can create your own plugin for any device, even if it's not in this list. And so there's a open source format that we have called the simple streaming specification. And as long as your firmware implements this specification, you can actually use it within the data capture lab. So I have this custom sensor here sitting with me. I'm going to go ahead and connect to it. And so I just wanted to point out, we do support 3 different connection types in the data capture lab. And when you build a model, which is Bluetooth, serial port, and Wi-Fi, TCP/IP. And we support, like I said earlier, this sensor happens to have an accelerometer and microphone on it, but you can add your own sensors and it can be whatever you want it to be. All right, so now that I have my sensor connected, I'm going to connect over serial. I've already set up this connection, but you can change your connection method over here. And I have this device sitting on my desk. And so a big thing we think is important as you do data collection is that we find useful is seeing the data happen in real time. So I have this device sitting on my desk. I'm connected to accelerometer right now, and I can see the data coming in. So first, I'm just going to show an example of just collecting a file, and then I will get into how to label that file. So I'm going to hit start recording down here. And now I'm collecting real data from this file. And so, this is our boxing demo. I'm just going to collect some noise data here. And you get the save confirmation screen. The important part here I wanted to point out is the file metadata. And so you can add any sort of custom metadata you want to your files. And so this is an important feature because, like I said, it's an iterative process to build a model. You're going to be retraining a model. You're going to be adding new things. You're going to find out maybe I need a different model for a right-handed person and a left-handed person. And then the other thing that's cool about metadata is you can set up, we typically always have metadata on our projects that are a training set of data and a test set of data. So you can leave data out of the model and pull it in and do testing on it later. And like I said, this is all customized to be whatever you want it to be. This just happens to be what we use for this project. For other projects, we might have other metadata. And so it's a movement file. It's just some noise that I added. So I'm gonna hit save here. So when you save that, it's gonna automatically add it to your project. And so this is the Project Explorer. I'll go over this in more detail later, but you can see here's our file we just collected. And I can open that file. And next I'm gonna go over how to actually add a label to this file. And so this is kind of the standard approach to labeling. I'm going to be getting into a lot of the automated tools and ways that we make this much easier for you. But typically you can see your file data, you can right click on the graph, and you can add a segment across the data. And when you click edit here, I can say that this is some movement data and click done and hit save. And that's how the typical way you would label a file. But let's go back to capture mode. And so when you are labeling a file, that was a short file, that was a 10-second file. You might be labeling it for more than 10 minutes. You might be labeling for an hour. I'm going to point out the live labeling part of the data capture lab. So you can add labels in real time as you're doing data collection. And so if I click start recording here, and let's say I want to do some jab labels, I can click jab and do a jab and click done. And so, this is a small file, but if you're doing 10 minutes of data collection, to go through and custom label everything after the fact, it's just kind of wasted effort and time on your part to do that when you could just be labeling it in real time. So I'll hit save here again, and we'll say that this is a jab file. And you get a review screen, so in case you messed any labels up as you were labeling, you can edit them here and change them or delete them if they were bad labels. And so here's our new jab file. So you can see it added the label in real time. Then the other major, I think this is one of the biggest features in our data capture lab, is the ability to, we have this test model tab up here. And once you've already built a model, like I said, chances are the model is not going to be great the first time you build it. And you need to add new training data to make it better. So we can actually connect to a model in the data capture lab and see the model results happening in real time. And then not only that, and so this is a good way to test it, let alone retrain your data set. But so this is a good way to test it and see it happening. We're emulating the model right now, and you don't even have to flash it to a device yet. So even if you haven't set up your firmware yet for models, you can test it out right away based on your training data set. And so if I click start recording here, I can now actually save these results as they happen in real time. And so, let's say, right now this is resting on my desk, and if I just barely touch the sensor, it's coming up as movement. But maybe I don't want that movement to be classified as movement. Maybe I want all of these just light taps to be considered resting. And so it's a false classification. If I hit stop save, or if I hit stop recording here and say this is movement again, here's all the labels I just collected. I can highlight all of these, say that these are actually going to be resting, and click save. And if I open up that file, this file has already been labeled with all of my resting labels, and that's from the model. All right, and then so next, we just showed how to connect to a model in capture mode. Not only can you do this in capture mode, but in the label explorer, move this out of here. In the label explorer, here's our project view, and this is all of the files that I've already collected before this session. And you can see I have my metadata up here, and you can see I've left out some test files here. And so I can actually highlight a list of files, right click, and use that same, so we call a model knowledge pack in our toolkit. We can use that same model to label these files after the fact. And so I just ran that model across these files. This is the results that it came up with. I could change them or edit them. And so you can see the file name is jab. And so it looks like we had one false classification in this based on that model. And so I would want to, if I want to, which is actually pretty good, but if I wanted to improve my model, all I would have to do is edit that label and change it to be jab and hit save. And now that these two files that I just selected are all labeled as JAB instead of and without those false classifications, and that's all from the model. So I could do this, I could essentially relabel this entire project based on that model within seconds. And so it's an extremely powerful tool to be able to connect to your model and see the results, and then relabel and retrain your model with those results. So I'm going to actually clear out these segments because we don't want them as part of our training data. And so, you know, I just went over the efficient way we have this feature right here from Knowledge Pack. But I'm going to skip over these three features and move on to the next part, but I just wanted to just mention them. We do have three other features for bulk updating files in the Project Explorer. So you can highlight a list of files and add your labels to them through all four of these features. And I suggest checking them out on our website. But so before we move on, I wanted to point out a more detailed view of the file open screen. And so, so I've opened up a file here. You can see I've labeled this file. There's four labels for uppercut right here, 3 labels for hook right here, and 3 labels for jab right here. I'm going to first go over the media player down here in the bottom right. So if I clear out all of these labels, and looking at this data set without any labels on it, it's pretty hard to see what each of these gestures are. You know, they all look pretty similar. We've got a high range on the gyroscope. You know, the accelerometer looks all pretty much the same. Without a video to see what's going on, it would be pretty hard to label them. And so I have this video I collected here. I was actually at Embedded World last month in Germany, and I collected this video at Embedded World. And so you can actually play a video with your file and see how it's labeled. So if I click play here, you can see the video view right here, which can be pulled out into another screen. And you can see this line right here moving across the graph. And so I can see each of these are uppercut right here, and then jab, and then, and then hook, and then jab at the end. And so this video feature is also a powerful feature for making it easier to label data. I forgot, I meant to mention this too, in capture mode. We also support, while you're doing the live data collection from your device, you can also connect to your webcam. And so since I'm using webcam in Zoom here, I would not be able to do that right now, so I skipped over it. But connecting to a webcam means that as you do your data collection and you go and open up those files, it will automatically show up as videos in your files. So the other feature I wanted to highlight in this screen is, so we have this concept of a track in the data capture lab. And so you can see here, I have a track for my gyroscope data, a track for my accelerometer data, and I can customize the height and range of these tracks. I can lock the y-axis, set my own specific y-axis range. I could add a new track. And so if we look at this data here and we zoom in, you can see the gyroscope y-axis right now is kind of encompassing all of this data. And so maybe I want to pull out that axis. I can easily do that by clicking update columns, taking out gyroscope Y. And I could add a new track if I wanted to, add gyroscope Y to that new track, and take a closer look at how that affects the data. And so this is all great for, you know, the first time you label, but I mentioned, you know, when you're building a model, you chances are will have to edit your data. And so if I built a model and decided that all of these labels here were maybe too small. They're pretty tight on each of these events. Let's say I want to make them a little bit wider. Technically I could go in here and one by one make each of them a little bit wider. Or I could move them over left and right. But it's a pretty time-consuming process. This file or this project has hundreds of labels, or probably over hundreds of labels in it. And we've had other projects that have thousands and thousands of labels in it. It's a big ask to ask someone to go through and manually update each of the locations if they need to edit it. So we do have a tool that allows you to highlight a list of labels, right-click, and we have 3 different options down here. We're going to focus on this adjust length right now. So you can adjust length. And so looking at the length right here, they're all about, roughly 70 to 75 samples. We're going to make them a little bit wider. So let's set our length to 110 samples. We can anchor the location. We can make it 110 samples from each of their start locations or the center location. But since these are all pretty centered, I'm going to go ahead and make the anchor location from the center and expand out. And when I click done here, all of the labels are now the same exact length. They are from the center and they're a little bit wider now. The other big thing here that I'll focus on is adjust location. So same thing as length, except for it's just moving the labels left and right. So you've got the right length, but you want to move them over a little bit. You can click adjust location. And let's say I want to move them, we'll go 15 samples to the right, click done, and they all just shifted to the right a little bit. And so with these tools, it just really speeds up the labeling process. And like I said, I didn't go over some of them. I didn't do the adjust size feature, but and then there's also a tool down here for if you don't know exactly how far you want to move it, you can turn on the move toggle right here, and you can use your keyboard to move them over by using your keyboard. And you can see on the segment tab up here, they are all moving left and right. And then the final thing I kind of want to go over is some more parts of the Project Explorer. So you can see here in the Project Explorer, here's our metadata that we've added that I mentioned earlier. We have our training set data, how tall someone is, what kind of if they're right-handed or left-handed. The other thing I wanted to point out is the label distribution column here. And so, you can see all of these labels that have already been, all of these files that have already been labeled, and you can hover over this label distribution column and see the breakdown of the labels in those files. And so, this file, it looks like it has 2 different labels in it, but if I highlight over that, it's actually 98% the right label. There was 1 bad label in here. And so so this is great to see it on a file by file basis. Another nice part is you can actually even highlight a list of files, and let's highlight the whole, let's highlight all of our files in the project, and you can right click and see the label distribution based on the selected files. And so this is a good tool for seeing your total distribution in your project. You can see the project breakdown of all your labels. The jab, hook, uppercut, overhand labels are all pretty even. They've got about 20% each. You can see a breakdown by number of samples instead of, just because there's 373 jabs doesn't mean they're all the same length as the other ones. And so you can see the actual length breakdown of each of these labels. And so this is useful to see a good project view, or if let's say I wanted to look at all of my hook files, I could, or let's see jab files, because it looks like there are a couple files that have mixed results in here. I can do that same thing and see, okay, 99% of it was successfully classified as jab. And so, yeah, and so that's kind of the wrap up of the Project Explorer. There's other columns here, like you can see how long a file is, how many segments are in each file, and you can organize by all of these columns. So if I want to organize by label distribution or the time it was uploaded, or let's say I want to organize all of my test files out of my training set files, I can do that, and then use that same model feature to test out those files. And that is going to wrap us up on the data capture lab. And so, as you're doing all of these labels, the data capture lab is uploading these up to our server. Like I said before, it also saves to your computer. So I right click open in Explorer here. You can see all of these files are just sitting on my computer also. And also, like I said, you can export your project out to a JSON format. This is not a proprietary thing where we don't have your data locked down. You can take it with you. And so I'm switching now to the Analytics Studio, which is the second tool in our toolkit and one of our the main tool that's going to be used for building the actual model. And so I've already connected to this same project, and the first screen that comes up in the Analytics Studio is the project summary screen. So it's just a basic screen to tell you information about your project, how many models are in your project, how many labels in your project, number of files in your project. But the more interesting screens are coming up. The prepare data screen is where you can create a query to select all of your labels. And so this is where you would use that metadata that I mentioned to pull in your labels into the training data set. And so you can see this query filter down here. There is, I said that I want to pull in only my training data, and I want to only pull in the right-handed labels. And so by doing this, we were able to make a right-handed glove and a left-handed glove model because we found that it wasn't accurate enough to use one model for both. It was very easy to just add a new query filter to it and say, only give me the right-handed model for this model, or the right-handed data for this model. And so we have a left-handed glove and a right-handed glove query. And so now here's the build model screen. This is where the most important part of this, the AutoML model building process happens in our tool. And so I'm gonna hit create new pipeline here and just talk about this for a little bit. Using our tool, we do have what we call a SensiML AutoML to automatically take that training data that you've collected through the data capture lab, and we're going to try and spit out a model that is going to be able to detect that data. And so, this is a great tool for getting started, or maybe giving you a guide for tweaking your model. But you can turn that off, and you can actually see, you can select your own classification algorithm. We've got TensorFlow Lite, decision tree ensemble, our pattern matching engine, several different classification algorithms. But for getting started and getting a good sense of what would be some good starting parameters, we do suggest using the AutoML tool. Once you actually create the pipeline, so I've already got these pipelines created just to get going quickly. You get the steps that are going to be used in that pipeline to train the data. And so by default, we just have a simple view to show you what kind of parameters we use. Here's our right glove query that I mentioned earlier. Here's the segmenter, the windowing segmenter that we use. But you can turn on the advanced settings here and drill down and change the steps yourself if you know what you're doing. And so, we have all these different steps. I'm not going to go through all of them, but I will point out a couple kind of key ones, which are the feature generator step. You can see the features that were used in this step. And not only that, and so this is just the features that were automatically selected for you, but you can edit them and change the properties that were used in each of the features. It doesn't matter to us that if you change them. So, it's up to you. And then you can also add other features. We have a whole list of all of these features to add. So I'll quickly just mention some other things. So we've got our outlier filter step here. We've got our feature quantization step here. And then the other big step that I will spend a little bit more time on is, by default, we selected that AutoML parameter, and we selected the classification algorithm already for you, but you can turn on custom training here and click save. And you can actually see the classifier that was used here. It pops up after you turn off, or when you turn on custom training. You can edit that. You could change it to be the classifier, any classifier you want. Or you can actually see the parameters in that classifier and change them to anything you want. And so this model happens to use TensorFlow Lite, and we could tweak these parameters if we knew better. So from there, I've already ran the optimize feature, and so it ran through all of these steps and spit out some model results here. And so this is the model results view. After you click optimize, it will spit out the top 5 models that it found, and it gives you kind of an accuracy and a little bit of a summary information, how many bytes of data the classifier will be. Oops. And number of features, sensitivity. And so based on the accuracy and some of these features, it kind of ranks them in a certain order that we think is useful based on the accuracy versus complexity. And so once you actually have one of your models and you want to take a look at it, you can click Explore Model here, or you can click Explore Model over here on the left-hand side. And I'm going to take a look at just one of these models just to show you kind of the things you can see about a model. And so first tab is a model visualization tab, and you can see a feature plot of the different features in the model. Second tab is the confusion matrix for the model. Third tab is the feature summary of the features in the model. The third tab is just the model summary of the classifier. The second to last tab is pipeline summary, which is just how the model was trained. And knowledge pack summary, which, like I said, knowledge pack is a model, so it's just how the model how the code will be generated for the model. So before we get to actually generating the code that will be on the device, we're going to go to test model right here. And so similar to the data capture lab, you can select a list of files in the Analytics Studio, and you can hit compute accuracy here, which I'm not going to do right now for time, but what it will do similar to the data capture lab, it will use the model to emulate the results of the model through our tools and give you an accuracy percentage. And it'll also, what's different from the data capture lab is it will give you a ground truth versus predicted results view, and it'll also give you the confusion matrix of the results. And so now we get to the download model tab. And so this is where we will generate the code that will be put on the edge. This entire time, we have not actually even had to flash your device. All of these tools really speed up the process of checking if your model is going to be good without having to flash your device. Saves you a lot of time going back and forth between flashing a device, testing it out, going back, testing it out, going back. It's a time-consuming process. And so now we get to actually generate the code. It does get generated as C code, and we have 3 different formats depending on the platform you use: a binary, a library, or a source code format. You can see more about those in our documentation. But I wanted to focus on the different platforms here. So we support 4 different compilers right now that we're constantly adding more. We got ARM GCC and generic compilers. We have in that the same kind of view that I mentioned in the data capture lab, we have all these supported specific hardware platforms from a lot of the big players. But even if you don't see your device in this list, you can still use it. It's similar to the data capture lab. We do have that same format that I mentioned earlier, the simple streaming interface specification that even if your device is not in this list, you can still generate the code for it and hook it up into your firmware as long as you implement this same firmware specification called our simple streaming format. And so, and the other big thing I wanted to mention on this screen is, not before you ever even compile your generate your code for this model, you get to see what the expected memory usage will be. We rank all of the features in our in the model to give you an estimated memory usage before you actually even put it onto the device, so that you can, if you are memory constrained, you can tweak your model to maybe fit better. And the other big thing is estimated latency. So you can see the latency that this model will affect, how this model will affect your device's latency. And so after you select platform, you get different options for building on the platform. You can select different options here, compiler options. One feature that we have is some platforms have an accelerometer. So this is Silicon Labs XG24, which has one that we've supported. And yeah, from there, here's where you can select output. This device happens to just be serial, but again, we support BLE, Wi-Fi, TCP/IP, or serial, and then you would click download. We're not going to download this now because just for time, we're just showing the end-to-end workflow. But yeah, from there, it'll generate, like I said, it'll generate C code that gets downloaded to your computer. You can flash to your device. In our documentation, we have all this list of supported devices out of the box, our supported compilers, and there's where the steps, each of these devices have different flash steps, but they're all documented. And so, yeah, that wraps up the end-to-end workflow. After you've built the model, you would test it out. And so I wanted to just point out 3 other things that I did not, or 3 other tools in our toolkit that I did not show. So we have, in our documentation here, we have the SensiML test app, the Open Gateway, and the SensiML Python SDK. And so the SensiML test app and the Open Gateway, they are tools for once you flash your device with the model, you can see the results come in. They're also good tools for demoing the results. You can add pictures to them and connect to your device and see the results coming off the hardware. And then the other big one I wanted to mention and just put a little bit of a time sink into is just the SensiML Python SDK. And so the SensiML Analytics Studio here, what I just showed, all of this, is our graphical user interface for our tools. But all of the things I've done here in building the model, we also have a Python SDK that can be run in a Jupyter notebook, and it's good for really drilling down into the features of your model, and maybe you want to do some testing and graphing using Python libraries that you want to use that don't exist in our tool. You can do that through the Python SDK. And that is it for the end-to-end walkthrough. So just kind of a wrap up. We just walked through doing data collection and making it easy to label your data, building a model, and then flashing that model. Everything I showed today, you can use our free community edition and walk through the same steps and see if your device is going to work. And I do suggest after the fact going into our documentation and checking out some other tutorials to see each of these have screenshots. And even if you don't want to try out the software, you can kind of check out all the different features of our tool in a more detailed way. And so, yeah, that's it. We'll open up for questions.
Mark, you must have covered it really well. It doesn't look like there are any questions online yet.
All right.
You guys have any? I don't know. What's the question you always get that you'd like people to know the answer to?
Yeah, we do. Ehsan.
So one question just popped up.
Okay.
Does the solution provide source files?
For the yes, so we do have so based on your tier of plan, we provide the source files for. I'm assuming you're referring to the model,
the final knowledge pack, basically.
Yeah, the model. When we generate the code, are you talking about the model source?
Yes, basically in the end. When you generate the knowledge pack in the end, you have the library and you can also get the source file.
Yeah.
Yes. Basically, it depends on your level of subscription, but we have the possibility of providing the source codes. So you can just download the source codes and you can go through the code and adjust it for your device if your device is kind of different, or if you want to compile your source code using another compiler. There is another question. What about MLOps tools integration like source and version control, model monitoring, feature store, model registry, etc.? So I can answer to this question. So for version controlling, so we are version controlling our labeling in data capture lab. So we have the concept of sessions. You can just generate labels in different sessions. So we kind of version control the sessions or labels. And also when you generate models in Analytics Studio, each model has its own unique ID. You can just generate different models or generate different kind of pipelines to create those models. And based off those models, you can generate different knowledge packs. So in the end, you have like AutoML results, and all of these model names are stored. You can just download them. And the other thing, yeah.
Oops. Sorry, I mean, you're probably just about to say this, but the other big thing too is, so, I showed these pipeline steps, and, there's a lot of things in here that are very specific to this pipeline. I forgot to mention this. I actually planned on mentioning this. You can export this pipeline into a JSON format. And so and this lets you both, it's a way to make sure that pipeline is saved to your computer, and then you can re-import it. And so it's also a good way to share pipeline parameters between projects. Sorry, I cut you off, Ehsan. Did you have anything else?
Yeah, also another thing that we just added is that whenever you train a TensorFlow-like model, for example, the initial parameters are random, and you may end up with slightly different models in the end. We have a way to store all of those models as well as you just work through your pipelines. There is another question. Discuss a bit about pre-processing versus raw data in terms of latency and accuracy. Basically, the pre-processing, if you mean by pre-processing, the pre-processing that you do on the data, we have some kind of ways to do that. Like if you show the pipeline, basically when you start from the top of the pipeline, you have the windowing. Basically, it says how you just segment your data or how you extract different regions of the labeled data. That window size determines what kind of features you are generate after the fact. And then you basically generate features based on the features you've selected. And we have some kind of min-max scaling. You can scale your parameters because we are gonna deploy these models on on edge devices. Most of them are like 8-bit devices, so you have to just scale those parameters. And basically, you can just scale them, like you can, and most of those pre-processing happens in the feature generation unit. So if you select any specific feature that requires some specific pre-processing, you can change those parameters and you can kind of control the flow of the pre-processing there. Another question, is there a way to monitor model drift after deployment into device? Yeah, I can answer this too. So basically, when you generate your model, if there is any drift, you can see that you are kind of losing accuracy. So then you can just go to data capture lab. You can just have the data capture firmware on your device at that time. Again, you can try that model on your on data capture lab on your new data and see if there is any drift. And if it's happening, you can go to the live session in data capture lab, or you can collect more data. And of course, your knowledge pack, because it's been drifted, it generates wrong labels. You can modify those labels. You can go back to the pipeline, model pipeline, and retrain the model and end up with the most current model that works the best with your current data. All right, I don't have any other questions. There is one more question. Data resolution importance and performance balance. Basically, for IMU data, we have the capability, it's based on the device also. We can capture data with different resolutions. So for different applications, you may end up with different sampling rates, and you may end up with models that work better with a specific sampling rate. You can definitely change the sampling rate and you can play with that. And also the performance balance, if you mean by that the data balance or the label balance, sometimes you end up with a data set that is imbalanced. You have more of a label compared to the other labels. So in the pipeline, we have the capability of balancing out your data. So we are randomly select from your data. There are different data points until you end up with a uniform, totally uniform label distribution. That way, we make sure that our model is not kind of biased towards a specific label. Also, a little bit of discussion about multiple data sources, sensors, and model complexity. So right now, basically, Marc explained it a little bit. We can have data being produced by different sensors that are coming from the same device, or even if they are coming from different devices, at least we can just store them as a CSV file. We can upload them, we can label them, and we can work with them. And model complexity, basically the complexity of model depends on the complexity of the data. If you use the AutoML features, basically it tries to find the best model for you. It uses a genetic algorithm in the background to just explore different combinations of models and different combinations of the features. Because even if you choose a lot of features, these are all potential features or candidate features. They are not gonna be chosen by your AutoML in the end. So the AutoML tries its best to find the best combination. And basically, model complexity can be also, if you are using the TensorFlow Lite, for example, you can define the complexity of model yourself. If you go to Mark, if you go to the TensorFlow Lite parameters, yeah, here in the dense layer, a little bit scroll up. Here in the dense layers unit, you have the possibility of choosing different combinations. If you put 448 or 884 or whatever combinations of the layers, you can define the complexity of the model that you're trying to train. And yeah, how expensive is AutoML or how expensive is AutoML to run it on a local machine? So basically on your local machine, most of the time you can run it on a laptop. The kind of AutoML that we have, it's not that expensive to run. And the reason for that is that we are trying to build tiny models. And when you try to just explore different small models, it's kind of easy to train them and work with them. But since we are using genetic algorithm in the end, so we are running multiple models, multiple feature combinations parallelly, and that just accelerates that if you run it in the cloud. Is there support for recurrent neural networks? Not yet. We are just supporting the convolutional neural networks or dense neural networks. But since we are focusing on audio right now, in the future, we envision to have recurrent neural network. Can we use SageMaker new compiled models here? I mean, models that are already created using different platforms like AWS. Basically, if you download the binary file of your, if it's TensorFlow Lite or TensorFlow, you can download your model, you can quantize it, and you can feed it to our pipeline. So that model doesn't necessarily have to be trained on our system. It could have been trained somewhere else. You can just feed it to our pipeline and use it in our pipeline to make a knowledge pack out of it and then deploy it on your device. All right, there is no more questions. I hand it to you.
Awesome. Thanks very much, Mark and Ehsan. That was great. Thanks everyone very much. That was a great presentation from Marc and Ehsan of SensiML. I hope everyone learned a lot. I certainly did, about their tool and some of its features and capabilities. Again, we're just going to thank all of the tinyML strategic partners for all their support of the tinyML organization and helping us build the market. I'm going to go through a couple of the specific slides as we talk. I will also mention this is, as we've said before, a whole series of talks. So there are more of these deep dives coming up, kind of following on with a number of from other companies who have AutoML products. And as we said, this demo will all be available on YouTube. Please do check out all the links that SensiML provided here, and I'm sure get in contact with them if you have any further questions. I'm sure they'd love to hear from you and talk a little bit more about all of it. And I think I'm almost done. Lots of support sponsor slides. So thanks again, everyone. I hope you all have a great day. Thanks for joining us for this latest of the tinyML AutoML deep dives. Have a great day. Bye.